Let us consider the applications of UCM. The very first one that explain vehicle along a horizontal circular track. To understand the concept of vehicle along a circular track, let us consider a horizontal track on which a car is traveling. In the figure, there is a horizontal track on which a car is traveling, having certain radius r, with its weight mg acting vertically downwards, m be the normal reaction of a car. Okay. It is observed from the diagram that since the car is moving on a horizontal track, but it is initially perpendicular or it is initially vertical on the track. So when it is traveling, a force of friction takes place between the wheels of the car and the horizontal track. So that we have to first explain that in the figure. In the figure, there is a car moving on a horizontal track. There is a car moving on a horizontal track with a radius r. With radius r. Okay. It is vertical on the track. It is vertical on the horizontal track. Okay. So it is vertical on the track. So its a weight. So its a weight in the bracket, that is nothing but mg. We are observing in the diagram. It's a weight mg. It is acting. It's a weight mg. It is acting vertically downward. The weight mg acting vertically downward. Whereas the component n or the factor n, it is seems to be, it is vertical. Okay, it is vertical. We know that the car is traveling on the track. So during motion, a force of friction, Fs, it is also shown in the diagram. During motion, when the car is moving on a horizontal track, a force of friction takes place in between the wheels of the car and the horizontal track. So during motion, a force of friction that is denoted by the factor Fs takes place. Okay. Mathematically, it can be written as, that is the normal n, it is balancing the weight mg. That's why n be the normal reaction and it is balancing the weight. So n is equal to mg. Whereas the force of friction Fs, it is the component which is useful for centripetal force. So centripetal force, the general formula is mv square by r. Equation number second. Dividing equation 2 by 1. So what we get, that is Fs upon n is equal to mv square upon r into mg. So here the factor m gets cancelled here. Okay. What we can get? We get that is Fs upon n is equal to, what remains here? V square upon Rg. We get V square by Rg. But we are well familiar that the friction that is called as coefficient of friction denoted by the factor mu s. It is defined as, it is the ratio of limiting force of static friction and normal reaction. What do we understand by coefficient of friction? It is the ratio of limiting force of static friction and normal reaction, that is Fs upon n, denoted by the factor mu s. So we can write it here, mu s, that is coefficient of static friction. So mu s is equal to v square upon rg. Nothing is there, 1. Taking cross product. So what we get? V square is equal to mu s rg. Okay, or it can also be written as, that is V is equal to under root mu rg. So this is the general formula for vehicle moving along a horizontal circular track. Let us consider the second application of uniform circular motion related to well of death. What do we understand by well of death? In the figure, there is a vertical cylindrical wall named as well of death, having certain radius r. In the well of death, a person performs some stunt. Okay, what the person does? He moves the vehicle along the walls of the well of death. Okay, and during this motion, some forces acted that we can write mathematically. So the first starting para is that, let us consider there is a vertical cylindrical wall. There is a vertical cylindrical wall named as, we have named it, named as well of death. Okay, it is called as well of death, having certain radius r, having certain radius r, comma, in which what the person performs, in which a person performs some stunt, in which the person performs some stunt. What the person does? He moves the vehicle. He moves the vehicle along the wall of well of death. What the person does here? The person performs some stunt. He moves the vehicle along the walls of well of death. And during this time, what happens? During such motion, some forces takes place. Some forces takes place. The first one, that is N. Okay, and it is acting along horizontal. The forces, the very first force that is shown in the diagram, and it is the force which is acting along the horizontal. Okay, it is acting along the horizontal, whereas the second force, that is, it's a weight that we can write mg. It's a weight that is mg. It is acting vertically downward. It is acting vertically downward. Full stop. Both these forces mathematically we can write. Mathematically, above forces, mathematically above forces can be written as, that is n, it is the normal along the horizontal, that is useful for centripetal force, that is n is equal to mv square by r, equation number first. Whereas the weight mg, that is acting vertically downward, okay, the weight mg, it is acting vertically downward along the wall of the well of death. So your force of friction takes place, that is Fs is equal to mg, equation number second. But we know that, but the force of friction, it is always less or equal to µs into m. The force of friction, it is always less than or equal to µs into µs, it is the coefficient of static friction, m be the normal reaction. So force of friction is always equal, that is we can write, that is Fs, it is less than or equal to coefficient of static friction and normal reaction. Put the values. Fs, that is nothing but, we have already written here, mg, it is less than or equal to µs, as it is the coefficient of static friction, and it is useful for centripetal force, that is mv square by r. So which factor we can cancel here? Here the factor m gets cancelled. What remains here? That is g is equal to µs into v square upon r. Nothing is there, one taking cross product. What we can write? That is µs v square is equal to rg, okay, or v square is equal to rg upon µs, or finally v is equal to under root, we get here rg upon µs. That's all. This is the required formula. This is the required formula for well of death.